mathematics we have something called vectors. They play a significant role in the world of science, and today I want to tell you a little bit about them. Here's an example of what a vector might look like. Out in the real world, vectors are often used to describe forces, velocities, or anything else that points in a certain direction and has a certain size. We can interpret vectors so long as they're in 2D or 3D. But today we're going to stick to two-dimensional vectors. Here's a vector, we can call it v. We'll draw an arrow on top of it, so people can see that v is a vector. The vector v can also be described as 2, 3, because in order to draw the vector, we went out 2 along the x-axis and 3 along the y-axis. Let's say we have another vector called w, and we're told that it could be denoted as 4 minus 2. What would that look like? We'll start by taking 4 steps along the x-axis and minus 2 along the y-axis, and we'll see that w looks like this. An important thing to remember about vectors is that you can move them around all you want. W is still going to be w just so long as you drew it by taking 4 steps along the x-axis and minus 2 along the y-axis. To better understand vectors, let's think of an example from the real world. Imagine you're playing curling. You shoot one stone into another to see what happens. If we want to know when number 3 goes after the collision, we have to know how hard you shoot and in which direction. Here comes number 2 and hits number 3 with a large force towards the right. That force can be shown with a large vector pointing right. But what if number 1 and 2 hit 3 simultaneously? Now we'll get 2 vectors, but number 3 can't move in 2 directions. So the resulting force must be something in between the red and blue. Somehow we're gonna need to add these 2 vectors together. And apparently when you add 2 vectors, you'll get another vector, which is exactly the one you'd get if you were to draw from corner to corner of the parallelogram made up by the red and blue vectors. It may sound a little weird, but the illustration here shows it well. You can also see that if you had shot the red one a little harder, the green one would have gone a bit more upwards. Likewise, if the red one were more slanted, the green one would have gone further to the right. And just like that, you can add vectors to get the vector you want. So let's try and add together v and w. We already know that the 2 vectors make up this parallelogram, and that the vector we get from adding them together, let's call it c, is going to stretch from corner to corner of the parallelogram. Let's see if it holds up. What you do mathematically if you want to add 2 vectors, v which was 2, 3, and w which was 4 minus 2, is to say that the x-coordinate of z must be the x-coordinate of v plus the x-coordinate of w. So 2 plus 4. The same goes for y, of course. So that must be the vector z, and we can just check again and see if it is in fact the vector you get if you go from corner to corner of the parallelogram made up by v and w. The vector z says 6 steps along the x-axis and 1 step along the y-axis, and it seems we did our math right.